This video provides an overview of the use of the ImageToGCode, GCode design software application. This software designs G-code for mills and routers based on image files. ImageToGCode is the first of two G-code design software applications that have been developed and marketed by Shooting Star Technologies LLC of Maryland, USA. ImageToGCode processes the pixel information of JPEG, bitmap, and PNG images to determine the cut and uncut regions in the pattern. ImageToGCode can process SVG images by converting them to PNG images, where the pixel information is used to design the G-code. The software application develops the G-code by rastering across the image data to determine cut and uncut regions. ImageToGCode can convert the desired image to black and white, where the image data can be processed in a white raised or black raised fashion. In addition, images can be processed in grayscale, where different shades of gray correspond to different cut depths. Images created from advanced software CAD applications or Adobe Illustrator or simple drawing software included in Microsoft PowerPoint, Word, or Paint. The user has control over the threshold values between black and white as well as the different shades of gray. ImageToGCode is organized with page tabs. The user proceeds from left to right in moving through the design process. The first tab is used to select the image file that is being processed by clicking on the Browse button. The image selected loads into the left view box. The file name and path of the file appears in the text box on the top left. The G-code file created appears in the same directory. Below the left view box is a text box that contains the threshold value that determines the interpretation of black and white, or the grayscale threshold to determine the separation of cut and uncut regions. A number closer to 1 means that values closer to white are interpreted as black or darker gray. With respect to grayscale, the user can choose 8-level, 4-level, or 2-level options. Pressing the Convert button processes the image with respect to the threshold values entered. The converted image appears on the right. Once user has adjusted the threshold values to obtain the depths of cut desired for the different regions of the image, the user moves on to the Settings page with the second tab. With the second page, the user enters the equipment-related settings that are incorporated into the G-code for the project. The user selects the units he wishes to use for the project, as well as whether the image will be interpreted as white raised, black regions cut, or black raised, white regions cut. Equipment-related settings such as the feed speed, spindle speed, and cutter diameter. The G-code is written in a cutter-dependent fashion where small features will not be enlarged by large cutters. In this way, the user can use a large cutter to remove material from large areas or features and then go back and cut small features with a small cutter. Project settings such as the width and length of the cut image, cut depth, and maximum depth per cut. The user can utilize a step size that corresponds to the pixel size of the original picture or a custom step size corresponding to an integral number of pixels. The G-code file is generated by pressing the Generate G-code button. When the G-code file is complete, an estimated time for the fabrication of the project is given. In some cases, the program will display an erroneous not responding message at the top of the window, but as long as the mouse cursor continues to have a spinning wheel, it is still running. The user is encouraged to wait for the program to complete its computations. The third tab provides a simple crop tool where a red rectangle shows the geometry of the cut image that the user entered on the settings page. The right window shows the cropped area. By using the slider and positioning the image with your mouse, the crop area can be set. Once the image is cropped, the user needs to go back to the first page and load the cropped image. There are many better crop tools available, so it is recommended the user utilize those to produce their picture. This simple tool provides a backup crop tool. The fourth tab shows the generated G-code and provides a text editor for the G-code file. This allows the user to inspect the generated G-code as well as make any custom changes desired. The text box in the top right gives the G-code file name and path to the file. The G-code can be saved to a different name using the Save button. The fifth tab displays a toolpath preview of the project that includes views of the multiple levels when grayscale features. The fifth tab displays a toolpath preview of the project that includes views of the multiple levels when grayscale features. The last two pages provide general information highlighting user responsibilities, information about Shooting Star Technologies, and contact information. Shooting Star Technologies provides post-purchase support to help the user get going in utilizing the program and deal with any issues that may arise. Now that we have overviewed the G-code designed software application with an image of a cat that has been processed as an 8-level grayscale image. The end result is an artistic image of the cat in wood cut with a 1mm diameter cutter. Let us go back and look at processing a sign using an image that is interpreted as black and white. The picture was created with Microsoft PowerPoint. The picture was created in color and is converted to black and white using ImageToGCode on the first page. Originally, the wavy lines of the image do not appear very strongly, so the threshold value is increased to make colors closer to white appear as black.